Hello everyone, and today I'm going to show you how we can find the second derivative of sine squared x plus 1. Now, I hope that in doing this problem, you realize something very important about the nature of a second derivative. So, one of the easiest ways to take a second derivative in solving this problem is to use the definition that it's just the derivative of the derivative. So, we can rewrite any second derivative just like this. Now, this might not always be the easiest way to do it, but in this case, especially when our degree is only 2, maybe if it was the 10th derivative, we'd want to look for a general formula. But in this case, this is certainly the simplest way to do it. Okay, so in finding the derivative of sine squared x plus 1, this x, the derivative is 1. The 1 is a constant, so it doesn't change, so this derivative is 0. We don't care about it. And then sine squared x, I'm going to write that in a separate area just to really emphasize how we can find this. So we know that sine squared x is nothing more than the sine of x and all of that squared. So this is a very simple chain rule problem where our outer function is x squared because we have the sine of x squared, and our inner function g of x is going to be sine of x. Now this tells us that f prime of x, so what's the derivative of x squared? That would be 2x. And g prime of x, the derivative of sine x, is actually just cosine of x. So this is everything we need to know to find our derivative. So now we can say that this is, so f prime of g, so 2 times sine of x, multiplied by g prime times cosine of x. Now you may notice here that there's a very important identity, a trigonometric identity, the double angle formula. So this is actually the same as the sine of 2x. Okay, so this is actually going to make it a little bit simpler, as you'll see in the next step of our problem. So now we want to find the derivative of sine of 2x and all that plus 1. So the derivative of a constant 1, as we saw earlier, is going to be 0, so we ignore that. Now what's the derivative of the sine of 2x? We'll write that again separately, just to emphasize it. This is another chain rule problem, this time where our outer function is going to be sine of x, and f prime, as we saw earlier, will be the cosine of x, and our inner function will be 2x, and our derivative, g prime of x, will be 2. Alright, so now we can simplify this by saying this is f prime, or the outer function, of g, so the inner function, so cosine 2x, and then multiplied by g prime, multiplied by 2. So therefore, the second derivative of sine squared x plus 1 is 2 times the cosine of 2x. But actually finding the derivative is not the most important part of this video. What you'll notice is that this is no different to the second derivative of sine squared x. So actually this plus x plus 1, these terms are unimportant. So any linear or constant term just goes away in a second derivative. And this is true for a third derivative, for example. Anything of lower degree than a quadratic goes away. So I would ask you to contemplate what this tells you about the nature of a second derivative, because we know that a second derivative represents the inflection point of a function. So is it true that constant values and linear values do not affect the inflection point? Well, this would surely say so. So think about why that is true for next time, and maybe I'll explain in a future video. Thanks for watching.